Welcome back to Math Savvy. Oh wait, I should probably say it's Maggie, right? The domain is essentially what are you allowed to put into the function.
Okay, wait, I did a horrible job of explaining this when I was filming. These are all of the functions that you're going to be tested on. They're all going to be negative infinity to infinity, except for the bottom three here. So again, the domain is what you're allowed to plug in as the x of the function. So if we look at the bottom three, these are the ones that you're going to need to memorize. The first one, 1 over x, we can't have a 0 in the denominator. So it's going to be every single number except for 0 is going to work as the domain. The second function is a square root function, and we know we can't take the square root of a negative number. So we cannot have any sort of negative number under the square root. So the domain is going to be 0 to infinity. But we can take the square root of 0. So notice how there's a bracket on the left side of the 0. A bracket means that it includes 0. So if we looked at the one before, it was a parentheses, which means 0 was not included in the domain. This last function is a log function. So you can't take the log of a negative number, and you also can't take the log of 0. So here we see again a parentheses to the left of 0 instead of a bracket like the example before.
Okay, that was like a good starting little like what the fuck is a domain explanation, I think. Okay, so let's go over the steps on how to find the domain of a function. So what you're gonna do, first step number 1, you're gonna draw a number line. Do this every single time. It's gonna be super helpful. Then you need to identify like, okay, what function am I working with and what are its issues? So we know that a square root can be 0, but it cannot be negative. You cannot take a square root of a negative number. So we need to find where the square root is going to be 0. What x is going to make this square root 0? And we know that -4, if we plug -4 in, it's going to make this function here 0. So once you find where it's 0, you have to plug in a number on the right and plug in a number on the left and see which one works. What do I mean by that? So if I plugged in a number on the left of -4, let's say -5, you plug that into x, that's going to give you the square root of -1. We cannot take the square root of a negative number. So we know that anything to the left of -4 is not going to work. But if we plug in something on the right, say if we plug in 0, that's going to be √4, that's a positive number, that works. So we know that everything to the right of 4 is going to be okay for us to work with. Your answer is going to be -4 with a closed bracket because a square root is allowed to be 0. The square root of 0 is 0. So -4 with a closed bracket all the way to infinity with an open parentheses is going to be your answer for the domain of square root of x plus 4. Let's try another example. We need to identify what kind of problems this function is going to have. So in this case, we can see that it's a fraction and we cannot have a 0 in the denominator of a fraction. So first step, draw your number line and then identify where the problem area is 0. The denominator cannot be 0. What x value makes this denominator 0? Well, it's going to be -1. So the only thing that doesn't work for this function is if x is -1, that's not going to work because it's going to give us a 0 in the denominator. So that's going to be the domain for this problem.
How would you use this? How would you incorporate this into real life?
Next problem. First step, identify the problem areas and draw your number line. We need to find what x makes this in here 0. So we can tell that it's going to be 0 at 3. So we do the same thing as before. We plug in a number to the left and a number to the right and see which one works. If we plug in, let's say 2, for example, this is going to be 2 minus 3, which is -1, a negative number. So that means it cannot be anything on this side of the number line. But if we plug in 4, that works. That's just the ln of 1. So we know that it can be anything to the right of 3. But it can't be 3 because 3 would make it 0, and you cannot take the log of 0. So the domain for this one would be 3 with an open parentheses all the way to positive infinity. So most likely on tests and quizzes, you're going to get problems that are fractions. So what you're going to do is you're going to evaluate the domain of the numerator separately from the domain of the denominator. So let's look at the numerator first. So we're going to draw our number line, and we know that a square root cannot be negative, but it can be 0. So we're going to find where this function is 0. This function is 0 at x is equal to 4. Now we plug in numbers on the right and the left. If we plug in a number on the left, it's going to give us a negative number in the square root, which we cannot have. But if we plug in a number on the right, it's going to be totally fine. So we know that including 4, everything to the right is going to be okay. So we just checked the numerator, good. Now we have to check the denominator. This denominator cannot be 0, so we're going to have a problem at 0. So we have to find 0 on our number line right here. We don't even really need to worry about it in the domain because it couldn't have been 0 anyway from up here in the numerator. So the domain for this answer is going to be 4, including 4, to infinity. Okay, let's look at another example. Again, we look at the numerator and the denominator separately, but we're going to draw them on the same number line. So, all right, let's first start with the numerator. We can plug anything into the numerator. There's going to be no issues with that. So right now, we're working with the entire number line right here. Everything's going to be fine. All right, check for the numerator. Now we have to worry about the denominator. Well, we know that the denominator cannot equal 0. But how are we going to find where the denominator is 0 here? We're going to have to factor it. So this denominator factors into x minus 5 and x plus 1. So it's going to be 0 at -1 and positive 5. And those are the only problems with this function. So it can work everywhere else besides -1 and 5. Okay, so your answer is going to be -infinity to 1, -1 to 5, and then 5 to infinity, and it's not going to include -1 and 5, so we're writing it with all parentheses and no closed brackets. All right, let's look at this example here. Again, we're going to check the numerator. It's just 1. That's totally fine. It can, that doesn't do anything for us. The denominator can't equal 0, so that means this here cannot equal 3 because 3 minus 3 is equal to 0. So we need to solve where x plus 1 in absolute value is equal to 3. Well, we know that when x is 2, 2 plus 1 is equal to 3. So what do? We draw our number line, right? Write down 2 here. But you have to watch out for absolute values because an absolute value could also be -3. -3 in absolute value minus 3 is just going to be 3 minus 3, which is equal to 0. So we need to solve where this is -3. And x is equal to -4 is going to make inside the absolute value -3. So -3 also doesn't work, and we have to put it on the number line. This function could be any number except for -3 and 2. So your answer for the domain is going to be -infinity to -3, then -3 to 2, and then 2 to infinity, not including -3 and 2. So again, parentheses instead of brackets.
Shit's complicated now.
Yeah. All right, same thing. First step, we're going to check the numerator, see what problems are there. It's a square root, so anything under the square root cannot be negative. So we find where it's 0, which is at 3. So if we fill in a number on this side, let's say 0, it's going to be a -3 in the numerator, which we can't have. So everything to the right of 3, including 3, is going to be fine. Now let's look at the denominator. Well, the denominator can't be 0, so we have to solve for when this is equal to 0. Okay, so x cannot equal 3 because if we put 3 in for x, this is going to equal 0, which we can't have. So even though 3 would have been okay in the numerator, it's not okay in the denominator. So we know that it can't be 3, and it also can't be less than 3 for this problem here. So our domain for this function is going to be 3 to infinity. All right, same steps. The numerator is good. We can plug anything into the numerator, no problem. So it's not going to affect our number line at all. Let's look at the denominator. Well, we can't have it be 0, so this cannot equal 6. So we have to solve 3x minus 3 is equal to 6 at what point for x? Well, if we solve this, this is going to equal 9. X is equal to 3. So x is equal to 3 is going to be a no-go. Because if we plug 3 in for x, the denominator is going to equal 0. But remember, for absolute values, it also can't be -6. Because absolute value of -6 minus 6 is still going to equal 0. Because the absolute value gets rid of the negative sign. So we need to solve 3x minus 3 is equal to -6. Because that answer is also going to make the denominator 0. So if we solve for what x is going to make that absolute value -6, we're going to get that x is equal to -1. So that means if we plug -1 into this x, it's going to give us a 0 in the denominator, which we cannot have. So we know that for sure -1 and 3 are not going to work for this function's domain. So we know that our answer is going to be everything except for -1 and 3. All right, this example is kind of tricky, and teachers like to throw this one in. So if we look at the numerator, no problem with the numerator, right? It works for the whole number line. Let's look at the denominator. We know that this denominator can't equal 0. Well, what number would make this denominator 0? If this x squared was equal to -4, then the denominator would be 0. But can x squared ever equal -4?
Oh, hell no!
Let's think. If we plugged in -2, -2 squared is equal to +4 because it squares this negative sign, making it a positive. So whatever number you plug in for x squared is going to be a positive number that comes out, because if you plug in a negative and square it, it's going to be positive. So this x could never be -4. That means there could never be a 0 in the denominator, because this x term here could never equal -4. So this is kind of a tricky question. All real numbers for this function is going to work. So our answer for this domain is going to be -∞ to infinity. This is another kind of problem that you might see. We know that this cannot be negative in here. We need to find where it's 0 and draw our number line. But first, to find where it's 0, we're going to need to factor this equation. So this function factors into x minus 1 and x minus 5. So now we can draw our number line and draw where our function is going to equal 0 on this number line. So it's going to equal 0 at x is equal to 1 and x is equal to 5. Now we do the same thing where we plug in numbers on either side of 1 and 5, because we just need to double check that inside here can't be negative. So if we plug in a number to the left of 1, let's say we plug in 0, that's going to be -1 times -5. Well, a negative times a negative is going to be a positive, so everything to the left of 1, including 1, is going to work. Now let's plug in something in the middle here. Let's say we plug in 2. If we plug in 2, this is going to be 1 times -3. But that's going to be a negative number. A positive times a negative is a negative. And we know that we cannot take the square root of a negative number. So that means this area in here is not going to work, because if we plug in the numbers here, it's going to be a negative under the square root. What's on the right side of 5? Let's plug in 6 for this example. That's going to give us 5 and 1. Those are two positive numbers. That's going to be a positive in the square root, not a problem. So everything to the right of 5 is going to work, including 5, because if we plug in 1 and 5, it's going to be 0, and we can take the square root of 0. It's just 0. So our answer for this one is going to be -∞ to 1 and then 5 to infinity. And they're going to be closed brackets, because we can have 1 and 5 in the square root, because that would just make the square root 0, which is equal to 0. We can have that. If you want more help on this, I'm always available for tutoring at math-savvy.com. See you later, alligator.